Now let's look at how to calculate some of these statistics in JUMP or using the Excel P from Z calculator or the confidence interval for two proportions Excel spreadsheet. Here is the ECMO data, how it would look in JUMP. You simply need to build a data set with 4 rows, and here originally 3 columns, and we'll talk about the proportion column in a moment. If you have a 2 by 2 table, then you will have 2 times 2 cells. That's 4 cells. If you go back and look at the table data, you'll notice the 57, 33, 41, and 46 all appear in the table for the ECMO data. And we can then now create a proportion for that data. So first of all, remember, I have designated the N as a pre-selected frequency. And you'll note that here by the blue circle with the counting marks next to it. It may be of interest for me to have the proportion of these survival rates in the table as well. This is done by creating a formula in JUMP. So let's actually delete this column and start over from scratch. So to create a new column, I can either add a new column under column information, or I can double click to the right here and create a new column. And I'm going to call this proportion. And what I need is a formula. And that is here in the column properties drop-down box. So select formula. Now remember, formulas in JUMP are different from formulas in Excel. In Excel, the formula is per cell. In JUMP, the formula is for the entire column. If I had equal sample sizes, I could simply take the N in each group and divide it by 90, and then multiply it by 100 to get the proportion. I can press apply, and we can go take a look here, and you'll see we get different answers for the CM group than we had in the notes or the slides, and that's because there aren't 90 people in the CM group. So let me go back to my formula window here. I'm actually going to copy this, so I'm going to say Control-C or Command-C if you're on a Mac. And I'm going to delete it and go back to no formula. I need to tell JUMP that there is a way to differentiate between the ECMO group and the CM group. There's a very simple way to do that in JUMP. There's a very simple way. Go into Conditional. You'll see this option called Match. The first thing I need to do is put my treatment group in the formula area. See, so select here and select treatment group. Now I want to hold the Shift key, press the Shift key down and select Match. And you will see that JUMP brings up a matching statement. So let's do that again. I'm going to delete this. I'm going to select treatment. I'm going to hold the Shift key and I'm going to select Match. If it's the ECMO group, then I know it's divided by 90. I still have my copied old formula, so I can actually paste my formula here. If it's the CM group, it's out of 87. I'm actually going to paste the formula here as well and just change this 90. I'm going to delete it and put in 87. So now, if it's CM, then I'm going to have a proportion out of 87, and if it's ECMO, I'm going to have a proportion out of 90. And I'm going to press OK. So you see how those change. Of course, this is very simple. You could enter those data in yourself, but if you have more groups, you'll see how formulas come in handy. Also, I'm going to fix here before I close out my decimal places to be 2 decimal places. Press OK, and now I have my proportions that I've seen before. I'm going to go ahead and save this. And now I want to do my statistical tests. I'm going to first, though, do my graph that we saw. So if I open Graph Builder, and so I can put my status of survival or my treatment groups, and it's a little bit funny in Graph Builder if I do survival and treatment group, and then right click and change to, say, a histogram. And it doesn't seem to make very much sense here. So you need to really think about what it is that I want out of my graph. What I really want to show is just the proportion that survived. So I'm going to close this out. I'm going to go back to my table, and I'm going to select the proportion that did not survive in ECMO. And I'm going to select, and I'm doing this by holding the Command key in a Mac or the Control key in Windows, the proportion that did not survive in CM. I'm going to go up to the Rows menu and Exclude. Now I'm only dealing with my proportion survival. So if I go back to Graph Builder, I can then put my proportion on my X-axis. I can put my treatment on my Y. And right now you can see they're only dots, and that's not very helpful. So if I right-click, I can change my points to bars. And you can see that now I have my ECMO and CM survival proportions. Over here on Label, I can label by the value. I can make this larger. I can click Done if this is what I want it to look like. And from here, you can actually use this large plus sign and cut and paste your whole graph into a Word document. You can also export or save these. There's more information on that in the JMP library. So that's how I've described my data. Now I'm going to go back and re-include my rows. So uncheck, exclude, unexclude. And you see now I have all of the data to work with again. For my statistical test, we had been in the distribution menu, but now we're going to be in the fit Y by X here. We have a predictor variable, that's our treatment group, and we have an outcome variable or a Y variable, that's our status group. I am going to put status as Y and treatment as X. And remember, since I pre-selected my N as frequency, it's already in there, and press OK. JMP brings up a few things for you. One is this mosaic plot. On the right side, far right over here, you can see what the proportion of surviving and not surviving looks like if we ignore treatment group. This is our P-bar. Now you can compare ECMO to the P-bar, CM to the P-bar. You can compare the did not survive in CM to ECMO. This is simply a visual display. This is not a useful graph for papers. The more useful graph is the one we built in Graph Builder. So I'm going to go ahead and hide this mosaic plot by just clicking on this little gray arrow right here. Now we have our frequencies. So we have our 2x2 table here, and JMP comes up with a few things by default. It comes up with the count, so those match the counts in our tables. It comes up with a total percent. That's this percent right here, and that would be 46 out of 177. It comes up with a column percentage. That's the second percentage here. That's 46 out of 79, so it's the proportion out of this column. And it comes up with the row percentage, and that's 46 out of 87, and that is the proportion that did not survive out of CM. So there's three different proportions we look at. We've been talking about the row proportions. We've been talking about 57 out of 90 or 63.3% here survived in ECMO. We've been talking about 41 out of 87 or 47.13% survived out of CM. We've also been talking about the overall survival rate, which is 98 out of 177 or 55.37. We've also talked about the expected values. That's an option you can get out of the contingency table. Up here in the red arrow, I can ask for expected value. You'll see here it will add another set of counts. These are not proportions. These are expected counts to the bottom. Remember, for a Fisher's exact test, if any one of these cells is less than 5, we'd have to use Fisher's. But since all of our cells are greater than 5, we can go ahead and use the chi-square test. I'm going to remove the expecteds, and I'm actually going to remove the total and the row percentage or the column percentages just so that we can see the row percents that we've been using. Remember, our null hypothesis here is that the proportion of survival is the same in CM as it is in ECMO. We're testing 63.3 equal to 47.1. Statistically, we're actually testing 0.633 minus 0.4713. That's our null. That the difference of those is 0. Our alternative is that our proportions are different. You can see here we get two chi-square values. The Pearson chi-square value is the square of our z. So if you calculate the z-score, that's your Pearson. The likelihood ratio test is another type of test. If you have large samples, this is a better test. I urge you to begin reporting the likelihood ratio p-value rather than the Pearson. We'll spend a little bit of time in this class talking about z-scores, but when we move to multiple proportions, we'll very quickly be talking about the likelihood ratio p-value. And we'll go more into why it's a better test than the Pearson. But for illustrative purposes, let's very quickly bring up the CI2 Proportions Excel spreadsheet. In the CI2 Proportions Excel spreadsheet, all you need to enter in are the counts in your 2x2 table. You do not need to enter the totals. Those are actually calculated for you. So simply enter in the cells here. It will then calculate your yeses, the opposite of your yes proportions, the parts of the standard error. It will give you the overall standard error, the square root of that standard error, and then it will give you P bar and the standard error for P bar. So the Excel spreadsheet here calculates everything you need to know. It will calculate the difference in the proportions. It will calculate the standard error associated with that, and it will give you your z-score. Here you can see down here at the bottom the chi-square and the z-score. And if you notice, this chi-square value, 4.702, is the same as the Pearson chi-square value in JUMP. So now that we know what JUMP is doing in the two different tests, we can go back to JUMP. Here is your Fisher's exact test. That option you can ask for on an exact test with Fisher's exact test. If you want to get the difference between the two proportions for a confidence bound, you can ask for two sample test for proportions. We've already done our test statistic, so we don't need to look at the adjusted walled scores here. What we really just want are the confidence bounds. These are slightly different than what is calculated using the CI proportion here, because again, JUMP uses a slightly different score confidence bound for the calculation of the confidence intervals, whereas in the CI2 proportions and the notes, we're actually using the normal based confidence bounds. But you can see they're very close here. The confidence bounds calculated by JUMP, the lower bound is 0.15, the upper bound is 0.301, and in our case, the lower bound here is 0.017, and the upper is 3067. So we get roughly the same. If you round it up, it would be 1.6 to 30.2, and in this case, it would be 1.7 to 30.7. So again, just like with the one proportion tests, if you do the CI2 proportion, that's the normal-based tests. If you use JUMP's proportion, those are the score tests or score confidence bounds. Make sure you say what your chi-square value is. Is it Pearson? Is it likelihood ratio? Are you going to report the z-score value? In any of the cases, our p-values are giving us very similar results. We're getting the 0.0301 out of the Pearson. You can bring up the P from Z calculator, Excel spreadsheet, and put in 2.168, which is our z-score, and look down here at the bottom, and we get a 0.0302 value from the P from Z calculator. We get nearly identical results from any of the tests that we use. Again, all of these tests are valid. They all have slightly different assumptions. You just need to state which test that you used and interpret it from there. So if we close this window, we can go back out to our JUMP data table, and we can save this for future use. And that is how you get statistical tests, either the z-score, the chi-square, or the Fisher's exact, as well as the difference in proportions and the confidence interval in proportions out of JUMP, or using the CI2 Proportions Excel spreadsheet, or getting your p-value out of the P from Z calculator.